Hi all, we'll move to the next question number 23. Okay, so let's read the question. Refractive index of water is measured by the relations m equal to real depth divided by apparent depth. He is found to have the values of 1.34 and 1.38, 1.32, 1.36. And the mean value of the refractive index in percentage, mean value of refractive index with the percentage error. So there are two set of values will be have given, it's given. We need to find out the mean value with the percentage error. Okay, so how to find out the mean value? Suppose x1, x2, x3 values are given, then x bar mean value will be equal to all the values divided by 2. So how many values will be here? 1.34 plus 1.38 plus 1.32 plus 1.36. 4 values are given. Whole divided by 4. Answer is 1.35. This is called the mean value. We need to find out the percentage error, which means delta x divided by x bar into 100. Okay, delta x bar. So mean value of the difference divided by the mean value is called this, it's called percentage error. So this is called the percentage error. So to find out this one, first we need to get the value of delta x bar. So delta x bar means we have to take each value and we'll find the difference, which means 1.35 minus 1.34. We have to take the modulus because positive will come, negative will come, and plus 1.35 minus 1.38, this modulus, and plus 1.35 minus the next value 1.38 modulus, plus 1.35 minus 1.36 modulus, whole divided by 4. So it is 0.01, 0.033, 0.8, 0.8 divided by 2 means 0.02. So 0.02. We have to find out the percentage error. Percentage error means 0.02 divided by 1.35 into 100. This is 1.48. So answer is 1.48 percent, 0.14. So into 100 means 1.48 value. So what will be our answers? A question is asking the mean value and the refractive index. So the mean value is 1.35. So our answer is 1.35 plus or minus the percentage error. What is the percentage error? 1.48 percentage. This is the answer. So answer is option A. Option A is the answer for 23rd question. We'll move to the next one. Question number 24, 24th question. If E is the charge, V is the potential differences, and T is the temperature, then the unit of EV divided by T. This EV divided by T, charge into, as I told, this is also called Q into V by T. This is called energy, W, energy divided by temperature. This is something, a parameter is called K. K is called Boltzmann constant. Boltzmann constant, remember this. Energy divided by temperature is called Boltzmann constant. K is called Boltzmann constant. Answer is C. Stephen constant will be there in option B. That is not there in the syllabus. Gravitational constant, capital G, already we found. Planck's constant, many times we have already seen in the previous question also. So this is called Boltzmann constant K. Next one, 25th. Question number 25. The dimension formula of the mobility is, dimension formula of mobility. Mobility normally representing using a letter called mu, and mu equal to drift velocity divided by electric field. This is an equation. These equations you will learn in your +2 class. You will learn it in +2 class, but it's come here because of the dimension. This is called mobility. This is called velocity. So velocity dimension formula LT raised to -1. Electric field we have to find out. How to find out the electric field? We have another formula will be there. F will be equal to QE is one formula will be there. Charge into electric field. So from here electric field will be equal to F by Q. Dimension formula of F is mLT raised to -2. Q means charge. Previous problem itself I told charge is equal to 80. Dimension formula is 80. So what will come? M a power minus 1 L t power minus 3. We'll substitute here for electric field M a power minus 1 L t power minus 3. So M power minus 1, A will go to numerator, so it become A. L and L will get cancelled. T is will go, so it will become T square. M power minus 1 and A, and it is T square. So the answer is matches with which options? M power minus 1, A and T square. Option is B. So answer is option B is the right answer for the 25th question. Move to the next question called 26. Two quantities A and B have different dimensions. Which mathematical operations given below is physically meaningful? Remember one point, a quantity which has same dimension formula can add, can subtract. Okay, but if your can add and can subtract, can equate. So addition is possible. If you look into option B, A plus B is given, right? A plus B and A minus B and A is equal to B. So equate A is equal to B and A plus B, A minus B. Addition, subtraction and equating two things are possible only if the quantities will have the same dimension. If it is a different dimension formula, then we can multiply and we can add. I will tell you one example. F is equal to ma. Here what factor is coming here? Multiplication. Mass in the dimension formula is m. Acceleration dimension formula Lt power minus 2. So different quantities means we can multiply. This is acceptable. Similarly, division. Velocity is equal to displacement divided by time. You will learn it in one dimensional motion. Dimension formula of displacement is La. Dimension formula of time is T. So a different dimension formula quantities we can divide and we can multiply, but we cannot add. But we cannot subtract, but we cannot equate. If you are equating, LHS equal to RHS, same dimension formula has to maintain. Similarly, if you are subtracting also, if you are adding also. But if you are dividing and multiplying, different dimension formulas are possible. So if quantities will have different dimension, then which of the following is possible? A by B, division is possible. Twenty-seventh question. Velocity of a water wave V may depends on their wavelength. There is one printing mistakes will be there. It's not small letter L. It is capital letter. It is lambda. Density of water is R. And the acceleration due to gravity is G. The method of dimension gives the relations between these quantities will be there, which means velocity is directly proportional to lambda raised to A, density raised to B, and acceleration due to gravity G raised to C. This kind of problem we already solved, right, many times previously. Lt power minus 1, here lambda means L power A, and this is density. Density means mass per volume. So m L raised to minus 3 raised to B, acceleration due to gravity Lt raised to minus 2 raised to C. So here what we'll do the next steps, we are equating the coefficient of L. The coefficient of L is 1 will be here. It is A minus 3B plus C, equation number 1. T in the coefficients we are equating. T in the coefficient is what? Minus 1 is equal to here no T, here minus 2C, equation number 2. M in the coefficient, this is the coefficient of L, this is a coefficient of T, and this is a coefficient of M. I am going to equate. Left hand side it is 0, right hand side no M, here also M, so it is B. Okay, so 3 equations we have. We can find out the values of A, B, Z, and we can find the relations. If B will be equal to 0 means this term is not there, this term is gone itself. So C equal to what will come from this equation? C equal to 1 by 2. Okay, then we have to find out the value of A. Will substitute here A minus 3B is 0. So plus C. C means 1 by 2 is equal to 1. A is equal to 1 by 2. Once we substituted, all these values will be here. Velocity will be equal to lambda raised to A. So lambda raised to 1 by 2 and G raised to C is what? The C is also 1 by 2. So this is the answer for the questions. Okay, velocity, anything made mistakes will be here. Velocity L t power minus 1, lambda wavelength A, and the density m L power minus 3. Oh, G is acceleration due to gravity. Okay, L t raised to minus 2. So first equation for L, 1 A minus 3B and C. Second equation is for T, minus 1 and minus 2C. So C equal to 1 by 2. And B is m 0 to 3B. So it's B equal to 0. So that's gone, and B equal to 0 and C will be equal to 1 by 2. We are substituting here, and A minus, so this is gone, plus C. A plus C. C is again equal to A plus 1 by 2 is equal to 1. A is equal to 1 by 2. So our answer is lambda raised to A. A means 1 by 2, and G raised to C. G is also equal to 1 by 2. So the answer is given, both will be equal to 1 by 2. Okay, so what is there given in the options? Oh, option is given like V square. So V square is given in the option. So V equal to lambda raised to 1 by 2 and G raised to 1 by 2. But what will come if you are calculating like V square? If you are squaring both sides, V square equal to lambda times of G. This is given in the option number B. In option number B, this is given. Okay, so whatever we got, we square it on both sides, so we get LHS will be equal to RHS. We'll move to next question, question number 28. Question number 28. The physical quantities not having the same dimensions are torque and work. Torque is called force into displacement. Work is also called force into displacement. So same dimension formula. The question is the quantity stress and Young's modulus. Okay, so this is option A. In option B is given momentum and Planck's constant. What is momentum? P is equal to mass into velocity is called momentum. Mass is m, mlt raised to minus 1. What's the dimension formula of Planck's constant? H is equal to energy divided by frequency. Energy is ml square t power minus 2. We already done this in the previous question, right? Time period is 1 by t. So the formula is ml square t power minus 1. So the dimension formula of momentum and the dimension formula of H is different. Question is asking which is different. Okay, all others are same. Stress and Young's modulus, same dimension formula. Young's modulus means stress by strain. That's a formula of Young's modulus. Stress will have dimension formula. Strain has no dimension formula. So same dimension. Speed and 1 divided by root of m0 into raised to 1 by 2. So the question is asking which is having the same, the physical quantities not having the same dimension. Answer is B, momentum and Planck's constant. We'll go into question number 29th. This is question number 28. Okay, this is question number 28. This is question number 28 we have written just now. So the answer for this is, answer is B. Okay, we'll move to 29th. 29th question. Physical quantities of the dimensions of the length can be formed. Length can be formed out of C, G and E square divided by 4 pi epsilon 0. So the universal G is a universal constant of gravitation, E is the electronic charge. So we have to check the dimension formula of every quantities we know. Gravitational constant dimension formula we know. E square means charge dimension formula we know. C is the velocity dimension formula also we know. What is the dimension formula of C? Lt raised to minus 1, velocity. Gravitational constant G, previously we have derived, and E square. So all the dimension formula, and 4 pi has no dimension formula. Epsilon 0, how to find out the epsilon 0? Here we are not going to find out epsilon 0 formula directly, but instead what we'll do, we know the formula F is equal to 1 by 4 pi epsilon 0 E square by R square. So 4 pi you can ignore anyway. 4 pi has no dimension formula, so it's a constant. You can ignore from the all the four options, and you can take e square by epsilon 0. What is the dimension formula of that one? E square epsilon 0 will have this, e square by epsilon 0 will have the same dimension formula of f r square, which means what? Dimension formula of f is ml t raised to minus 2 and it is L square. So it become ml cube t power minus 2 is the dimension formula of e square by epsilon 0. Then what are the factors we have? We have g dimension formula, already we found this one, and c will have a dimension formula. This also you know, this is called velocity. Okay, so we have to substitute in the four options and you have to find out which one is matches with this one. Okay, so you can check option by option. So first you have to list all the dimension formula, you substitute in option A, you substitute in option B, and you have to find out. So here answer is here, sorry for that, your answer is coming as option number D is coming as the answer for this one. Okay, which means answer D means here the length dimension formula is c square g into e square divided by 4 pi epsilon 0. So that will be comes as the dimension formula for the same. Okay, e square divided by 4 pi epsilon 0 g into, and this is whole power of 1 by 2. I already solved this one. That's what I am writing. The options directly will be here. L equal to c square g into e square divided by 4 pi epsilon naught. Okay, so you can you know the dimension formula of this one, and substitute and check each and every options, and after you cancelling everything you have to get the dimension of L for this one. Which option is giving L? That is the right answer for your question. We'll move to next question. Question number 30. Unit of impulse is same as. In your first year itself, in the work power energy chapter and in laws of motion chapter, the next chapter what we are going to learn from my side is laws of motion. In that chapter you will learn one concept is called impulse equal to delta P. Delta P is called change in momentum. Impulse equal to change in momentum. So impulse and momentum, change means difference, that's all. So impulse and momentum will having the same dimension formula. So answer is C4 in question number 30. Question number 31. If Q denote the charges on the plates of the capacitors, capacitancy and the dimension formula. This I already told in the morning. W will be equal to, there is a formula for energy, Q square by 2C. This is one formula. Okay, W by there I have written Q square by C, but the original formula with respect to work is, this is work, this is also called energy. Energy with the charge and capacitance, Q square by 2C. As of now you can by heart this one, but when we move to second year definitely this will be there in your mind, Q square by 2Z. So 2 has no dimension formula, but question is asking Q square by D dimension formula. This is the dimension formula of what called energy, energy in the dimension formula. So ml square T raised to minus 2. Option C is the right answer for question number 31. Okay. So we'll stop it here and we'll see the balance question. We have further questions from there from 32 to 45. We'll do it in the next sessions too. Okay. So thank you and have a nice rest of the day. Bye bye.